matrices 2 by 2 adjoint of square matrix. So we have a matrix A, and that matrix, each element has their position: A11, A12, A21, A22. Every matrix element has its sign number. A11 is +1, A12 is -1, A21 is -1, A22 is +1. And to calculate the adjoint of a matrix, we take the matrix A, and for each element in that matrix, we multiply the sign by the minor matrix of each element, and that gives the cofactor of the matrix, and then we transpose the cofactor, and the cofactor transpose is what we call adjoint of a matrix. The transpose is to change the row to column and every column to row. Matrix A, I'm going to turn into cofactor matrix, and we're going to populate that, and then we transpose that into the cofactor transpose, and that's the adjoint of a matrix. So we are looking for cofactor of A11, and that will be equal to the sign of A11, so that'll be -1, I is 1, j is 1, so -1 to power 1 plus 1 is 2. That will be +1, because -1 to power 2 is positive. That's why that's positive. So that's positive. So we times that by we get that matrix, so we're going to work out the minor matrix. We haven't done that yet, but we're going to work it out. We're going to do the same for C12. We get the sign for C12, 1 plus 2. That's odd number. Even number is always positive. Odd number will be negative. -1 to power 3 will be -1 times -1 times -1. That will be -1. So that's why this is -1. For every odd number, you get negative. For every even power, this is the power here, the exponent, you get positive. So we need to find the minor matrix of 2. And then we do the same for the cofactor for A21. That's 2, 1 there. So C stands for cofactor. We're going to do -1 to power 2 plus 1, 2 plus 1. Odd number, so we expect that to be -1, and that's why this is -1. And then we times that by the minor matrix for the element 3. And then we do the same for the last one will be to do the C22. Again, -1 to power 2 plus 2. That will be +1. And then we times that by the minor matrix for 4. So for the first one here, we do, well, -1 to power 2. That's -1 to power 2. And that will be equal to 1 plus 1. So that's +1 times. So that dot means times. And we want to do this is the element we're looking at. We'll draw a horizontal line and a vertical line, and the opposite here, that would be the minor matrix. So that would be times 4. That's times 4 equals to 4, which means I can populate the element for C11. So that would be 4. We need to do the C12. We want to find the cofactor for that one. Again, we multiply -1 to power 3. That's odd number, so that would be -1, and that -1, we want to times that by the minor matrix for 2. So we draw a line there, draw a line, and this is the minor matrix for 2. That will be times 3, and that equals to -3. We populate the cofactor element, and that would be -3. So we need to find a cofactor for C21 element, and the cofactor C21 would be -1. Now 2 plus 1, that's 3 again, so that would be -1, and -1 times, so that's times again you select the 3 there, draw vertical line, draw horizontal line, and that is the minor matrix for 3. That will be times 2, and that equals to -2. So you populate the cofactor matrix with -2 there. And now finally you want to find the cofactor element, C22, -1 to power 2 plus 2, and that is 4, and that's even number, so that'll be +1 plus 1 times, you want to times that by element, draw vertical line, draw horizontal line, and that will be the minor matrix. So that will be times 1, and that equals to 1. And so that will be 1. And now what we need to do is to do the transpose. Transpose means you turn the row into column and that row into column. That's it, as a transpose. But if you look at the cofactor and compare that to the matrix A, you can see there is an interchange diagonally. Interchange. This is for 2 by 2, by the way. This is only for 2 by 2, and another interchange, but then you multiply that by -1, and that's how to do that quickly. And now let's do the transpose. So you're going to get 4 -3 and -2 1. Compare the cofactor transpose with matrix A. You can see there's an interchange here, and then you just multiply these by -1. That's what you get. So if you can remember that, you can do that on a quick question, but to show you working, you have to show your calculation to go from A to C cofactor. You can say that you interchange that diagonally and interchange that diagonally, and then you multiply that by -1. That is the cofactor for the matrix A, and the cofactor transpose would be you interchange that and you just multiply this by -1. And now this cofactor is the adjoint. So CT is the adjoint of matrix A. The adjoint of matrix A is the cofactor transpose, which is that.